So just to review what we've been doing in this unit, we have been solving quadratic equations. How can you tell if an equation is quadratic? It's got an x squared in it, okay? And we came up with different ways to solve them. And remember, what was the other word we used now for solutions? Do you remember? Roots. Nice. Mean the same thing. Don't confuse that with square root because it's something completely different. So, what we've been doing basically this entire unit is we've been solving these quadratic equations using algebra. And depending on what the quadratic equation looks like, we solved it by taking the positive negative square root. We solved it by factoring. Or if we couldn't factor it, we used the quadratic formula. There is another way that you can solve equations, not just quadratic, but any equation, is using graphing. And before I describe that, let's look at an example. You are asked to solve this quadratic equation by graphing. But first of all, let's solve it using algebra. How do we solve this one? Can we take the positive negative square root? Is there an x term? Means we can't. Okay? If there's an x term, we either got to factor it or we got to use the quadratic formula. Factoring's quicker. Let's factor. That would give you -9 at the end. -3 and -3, good. Therefore, there's only going to be one answer in this. X minus 3 is 0, x minus 3 is 0, x is 3 for both of them. So there's only one solution for this. Graphing, here's how we solve it by graphing. Well, hello. Oh, that's nice. Okay. By graphing, here's what we're going to do. We're going to take each side of the equation and we're going to graph it. So what we're going to do is we're going to put a y equals in front of this. We're going to put a y equals in front of this. It is. So we get y equals x squared minus 6x plus 9. And y equals 0. So we got to remember how to graph these things. You should remember how to graph them from Unit 2, the quadratic functions. What's the first thing we need to do when we graph a quadratic function? What's the point we need to get? The vertex. Do you remember how to get it in this form? We had to find the x vertex, and then we had to plug that in to find the y.
Oh, yeah, negative b over 2a.
Negative b over 2a, which means we're going to get negative 6 over 2 times 1, which works out to 3. And now we got to find the y vertex by plugging that 3 in and calculating for y. This is unit 2. Three squared, 6 times 3. So we've got 9 minus 18 plus 9. 0. So that means that the vertex is 3, 0. Does it open up or down?
It opens down.
Why does it open up? Because it's positive in front of the x squared. Is it regular or is it stretched? Really? It's only stretched if there's a number in front. 0 for 2. It's okay. So up, up. Oh, come on, stop doing this to me.
I like the color switch.
Thank you. Up and regular. Something's wrong with that. Yeah, it's not the battery anymore. Something's happening at the bottom of the screen. It's not picking it up properly. So the vertex is at 3, 0. Sorry? 1 out, 1 up. And then, no, I thought you said, sorry?
4 up.
Thank you. Well, that sounded a little frustrated.
Yes.
That's the left side of the equation. No, that's the hard part. Because y equals 0, that's something that you learned how to graph in grade 9 and 10. What does y equals 0 look like? A horizontal line, where? On the y-axis? If you draw a line on the y-axis, that's vertical. Like this.
You need arrows to show the people.
Because every point on this line, the y value is always 0. So whenever you have y equals 0, it's a horizontal line. Circle the point where that line and that parabola meet each other. When x is 3. Ho, ho, ho. Mind blown. You may have, but I don't think so. Yes, but you haven't made the connection between algebra and graphing. So you can, now obviously it takes more work, but you can, and the algebra is much more efficient, but you can solve any equation, and we're just going to focus on quadratics, by graphing. Graph each side of the equation, put a y equals in front. One will be a parabola, one will be a horizontal line, always. Okay? Find the x value where they intercept. That's your answer. And there may be more than one answer. So notice the connection. Same. 3 exclamation marks. You know I'm excited when I write 3 of them. Actually, you know I'm excited when I write just 1. Although I usually write them at the end of your report cards. I do. You know, like, keep up the good work, McKenna! Exclamation mark.
Get doing your exercises.
Yeah, do your exercises, Lauren! Exclamation mark. Yeah, good times. Okay, so using graphing. So we graph each side of the equation. By putting a y equals on each side. The x coordinate where they intersect each other will be the solution. That's how we solve by graphing. We're going to see a little bit more of this in grade 12, where we use it to solve really any type of equation, not just quadratic equations. Okay? So let's look at a couple more examples, because I think it helps us to revisit how to graph. I'll just wait a second until everybody gets this down. We're good? Okay. This one. I'm going to use 2 different colors.
Yeah.
The right side of the equation is always going to be the same. The right side of the equation is going to be y equals 0, which is going to be the horizontal line on the x-axis. So we're already halfway done.
What?
The right side will always be the same. The left side is going to be a parabola. So we want to graph, toss a y in front of it. Y equals 2x squared minus 4x plus 5. And we use the same method to find the vertex. And then we see whether it opens up and whether it stretches, and then we graph it. So to find the x vertex, it's negative b over 2a, which will be negative 4 over 2 times 2. Sorry, which will be negative 4 over 2 times 2, which gives us 1. The y vertex, we have to plug that 1 back into the quadratic function. So this is 2 minus 8 plus 5. Sorry? Oh, yeah, sorry. Thank you. That's why I always suggest you write in pencil. Sorry, 2 minus 4 plus 5
Yes.
gives us? Three. 3? Yeah, 3.
Are you sure?
That's right. Up or down?
I got this. Up.
Stretch or regular?
Stretch.
Stretch of 2.
Yes. Wait. How did I find the stretch?
You look to see if there's a number in front of the x squared. And there's a 2 there. So the vertex is 1, 3. And now from here, I'm going up. I go 1 out, 2 up. And then I go 2 out, 8 up, but that's off the graph. This is enough.
It's off the graph on the test.
Don't do it. Sure, of course. So now this is where students make a mistake because they don't finish the question. They figure I've graphed both sides, I'm done. Remember, the whole purpose is to solve. So now we got to find where they intersect. Where do they intersect? They don't. Which means, is there a solution? No solution.
Wow.
No solution. You need to write that. And if we solve this using the quadratic formula, we would end up with a negative under the square root. Because that means no solution. Okay? So we're using our knowledge from the previous unit to solve these things by graphing. One more time. Again, we're going to graph each side. So we're going to graph negative x squared plus 4. And we're going to graph y equals 0, which will always be a horizontal line on the x-axis. So we've got that one. We don't need to do the negative b over 2a with this one. Think about it. If there's no x term, what is x squared? We all know where x squared, we know what x squared looks like, right? Where does it start? 0, 0. But this tells us what? Moves up 4, doesn't it? Okay, and this tells us what? It opens down. So the vertex is going to be 0, 4. It's regular, and it opens down. Because this is really vertex form. And remember, there were 2 types of forms. Vertex, we could just read the vertex right off the equation. Okay? So 0, 4, 1 out, 1 down, 2 out, 4 down. There are 2 solutions. Of course you do. X equals 2 and x equals negative 2. You'll see that if I took this say I was to solve this algebraically using algebra. Is there an x term?
No.
So this is where I'm going to do the plus minus square root. So I need to get x squared by itself, but x squared needs to be positive. So move this over here by adding x squared. So we get 4 equals x squared. Now, how do we find x? How do you get rid of the square root? Or sorry, how do you get rid of the square? Right, but not just the positive square root. And what is the plus minus square root of 4? That is just crazy. Notice they match. It's all connected. Graphing is connected to algebra. Notice all the points that we've been finding are all on the x-axis. Like in the first one, the solution was on the x-axis. The second one, there was no solution. And then the third one, both of them were on the x-axis. Okay? What you're really doing when you do this, well, what do we call points on the x-axis? We call them x-intercepts. And you guys learned in grade 10 last year, how do you find the x-intercepts of any graph? Always make y equals 0. Okay? So to find the x-intercept, make y equals 0. So I can actually find the x-intercepts without having to do all the graphing. So instead of y, I'm going to put 0 equals x squared plus 6x plus 8. Solve it. How are you going to solve it? What method? Can you do plus minus square root? No, because there's an x term. So what's the next one? I listed them all at the beginning of this lesson. If plus minus square root doesn't work, we try to factor. Should be able to factor this. X plus 4, x plus 2. And then we set each factor to 0, so x plus 4 is equal to 0. Therefore, one of our x-intercepts, because that's what we're finding, is negative 4. And the other one is negative 2. Remember when we looked at quadratic functions in Unit 2, we found the y-intercept exactly, but remember I told you at the time, don't find the x-intercept, just tell me how many there are. Now we can actually find them. You had to know how to solve quadratic equations in order to find x-intercepts of these. Now that you guys know how, we can do it. Okay? Okay. So for Wednesday, please.